Okay, folks, it's now 9:01 on Tuesday night, the 7th of April, 2026. We are, of course, looking at the Leo Trio. I'm going to do a 30-second exposure at 10 seconds each stack of this view, and then I'm going to do 6 stacks at 5 seconds, and we're going to get a chance to compare the two. Let's go ahead and get started, and we'll watch it from the beginning. Creating a new empty stack image. It will take some 30 seconds. It already says one stack. That's not correct. That's just an initial alignment stack. When it gets to 4 stacks, I will pause stacking. We're, of course, at 30x, 20% e-zoom. Okay, we've now achieved 4 stacks. Stack stopped, as you can see at the bottom of the screen. And I'm going to pause this video. Now we're going to watch 6 stacks accumulate for a total exposure time of 30 seconds. And this time I know it started with the first stack of 5 seconds. Okay, so we're continuing to follow it. We're up to 4 stacks. You can see the current image display down there. 4 stacks, 5, and then I'm going to pause. 6 stacks. Okay, now we're up to 1 further stack at 30 seconds, a single stack. And we're going to go ahead just to see for alignment whether or not we get a good view at 60 seconds next. Pretty much a 60-second stack begins with the last stack done at a shorter period of time, which is probably not a bad idea to do initially in most instances to begin with that. Fortunately, I only have 30 galaxies to cover tonight, so we can spend a little more time exploring exposure time and visible results on the screen. Of course, we could also explore e-zoom as well, but that could be a separate investigation later on. Basically, over time, you really learn to characterize how all this works. You're limited experience to begin with. I was an eyepiece astronomer, etc., etc. But with the decaying quality of our night skies and wanting to only use a smaller scope but get deeper views, I've migrated over now to using real-time imaging and the ZWO. Okay, so we should have a popping view in a few seconds of a 60-second stack. And I'm not seeing it. Huh. Apparently it ignored the first stack. So I'm going to bail on this now. We need to get going on the NGC 3700 to 3749 series, which will include one visual magnitude 15 plus galaxy, which will be interesting to see if we can turn up. Okay, another good way to assay, but at least sky conditions, is to see whether or not a particular galaxy is visible in the field at the first stack. This is 2 stacks now, and I believe there's 2 galaxies in the field. Going up to 105x, we have to choose between these 3 galaxies because the accuracy of GO2 isn't that particularly good. But let's describe it. NGC 3700 is a galaxy in Ursa Majoris, magnitude 14. It was visible from the beginning. Spiral with a bar, lowercase ab. 404 million light years distant, puts it about 135,000 light years in diameter. It's 1 by 0.7 arc minutes. It's right ascension 11, 29, 38 with a declination of plus 35, 30, 52. Since it's a spiral with a bar and a lowercase ab, it's 1 by 0.7. I suspect it's probably this galaxy right here, but it needs to be confirmed. AdventuresInDeepSpace.com. I wrote extensive notes up today. I will not be writing extensive notes and research with this video tomorrow. NGC 3701 appears to be visible right at the middle of the screen, and at 105x. It's a galaxy in Leo. The data hasn't popped up yet. Sometimes there can be delays in that. Sometimes it has to do with my pushing buttons in a faulty manner. NGC 3701, Galaxy Leo, magnitude 12.9. Not surprising, it turned up, but it's quite large, 1.9 by 0.9 arc minutes. Spiral with a lowercase bc, not much of a core. 129 million light years distant, puts it about 80,000 light years in diameter. RA 112928, declination plus 24 degrees, 5 minutes, 35 seconds, and we've had 8 stacks. NGC 3707, which was not quite visible, is a galaxy in crater, magnitude 15.2, makes sense. 0.6 by 0.4 arc minute elliptical. Wow, that's pretty faint right there in the field. I'm going to push it up to 150x where we can gather the most photons. I do believe this is it. Looks pretty faint, so it could be the visual magnitude. It's an elliptical 0.6 by 0.4, no distance. It could be a... Whoa. We've already skipped ahead to the one galaxy I knew was magnitude 15.4. So, we're going to have to do some research. This is right ascension 11:30:11 with a declination of minus 11 degrees, 32 minutes, 36 seconds. How did we ever skip that far ahead from 302? Let me go and research that briefly. Okay, NGC 3703 should have been the next entry. And it may very well have been the one. I just may have fumble-fingered 3707. This is a galaxy in crater, magnitude 14.7, 0.8 by 0.4 arc minutes, spiral, 503 million light years distant, so roughly 145,000 light years in diameter. Right ascension 11:29:09, declination minus 8, 26:46. Let's bump it up to 150x, gather as many photons as possible, seeing something vaguely suggested there, and then bailing. NGC 3704 is behind a power fraction line. Galaxy in crater, magnitude 14, largish for a 14th magnitude galaxy, 1.6 by 1.4 arc minutes. It's an elliptical spiral. We're going to push it right up. And maybe this one right here, but we're going to go to 150x and have a look around. There may be some suggestions of galaxies, but nothing definitive. It's a right ascension 11:30:04, declination minus 11, 32:47. Not a particularly good night of seeing tonight, but it could improve. NGC 3705, I think, is quite apparent right there in the middle of the field. Pretty good alignments tonight. Edge-on galaxy, apparently, in Leo, magnitude 11.1, 4.6 by 1.9 arc minutes, spiral with a bar, lowercase ab. 42 million light years distant, maybe 75,000 light years in diameter. RA 11:30:07 with a declination of plus 9 degrees, 16 minutes, 35 seconds. Not the best of skies, clearly, but they did improve over the last 2 nights out. NGC 3705 had a very close, reasonably close neighbor in NGC 3705A. Let's see where we're at. 105x view. Here's 3705. I suspect it's this galaxy right here, but it did not center up particularly well because 3705 did. A is a magnitude 15, 0.9 by 0.1, 9 to 1 aspect ratio spiral. Whoa, this could be it. 272 million light years distance, so about 80,000 light years in diameter. RA 11:30:29, declination plus 9 degrees, 23 minutes and 17 seconds. Let's do some 150x zoomage, gather some more photons, and I would say this is our NGC 3705A right there. Only the core is visible. There is also a fainter B galaxy, NGC 3705B, Galaxy Leo, magnitude 15.5, photographic, small, 0.4 by 0.2, so it has a high surface brightness, lenticular spiral, bright core, making it much more feasible, but 673 million light years distant. Wow. Probably the most distant lenticular I've run into. RA 11:29:43, declination plus 9 degrees, 12 minutes, 18 seconds. Unfortunately, NGC 3707, that galaxy that I wanted to see if we could turn up, which is magnitude 15.4 visual. It says 15.2 here, but I confirmed it on Steve Gottlieb's site. 0.6 by 0.4 arc-minute sized elliptical. Must be very distant. There's no distance value here. RA 113011 with a declination of minus 113236. Maybe we'll come back to this one later in the evening just to see if we can see 15th magnitude galaxies that are minus 11 degrees 32 minutes 30 seconds south declination. After a couple of bogus studies, we're now on to NGC 3710. I'm not really seeing it, but it is quite visible. Must be very small, kind of tightly bright. Magnitude 13.1, NGC 3710, Galaxy Leo, elliptical galaxy, 1 by 0.8, 294 million light years distant, maybe 80,000 light years in diameter. RA 113106, declination plus 22, 4604. And here is that 150x view of NGC 3710. NGC 3711 is a faint galaxy in crater, but fortunately it's not in alignment with a diffraction bar from a power line. Magnitude 15, 0.9 by 0.4 arc-minute spiral with a bar in lowercase bc. So if that is photographed, it's somewhere around magnitude 14.3 visual. 179 million light years distant, means probably about 60,000 light years in diameter. RA 112925 with a declination of minus 110448. Further north, we're looking for NGC 3712. Pushing it up and scanning. I'm still waiting on the data to come into the handset. Let's try punching the button one more time. I'm seeing a fairly faint galaxy right there. Ursa Majoris, magnitude 13.9, 1.7 by 0.6 arc minutes. I'm going to back out. It should be pretty close, maybe a little further down, but the brightest galaxy I'm seeing there, 13.9, is way off center. 75 million light years distant spiral with a bar and peculiarities. 1.7 by 0.6 arc minutes, right ascension 113109, declination plus 28, 3401. That's my best candidate. NGC 3713 seems to be visible in the middle of the field, right under the E-zoom. Very nice, and it's not very far from that last galaxy, so something was a little messy on that one. 3713's magnitude 13.2, 1.2 by 0.8 arc minutes, lenticular spiral, 317 million light years distant, maybe 100K in diameter. RA 113142, declination plus 280912. NGC 3714 may be visible right near the middle of the field. Yes, indeed. Wow, it's pretty impressive. It's a galaxy in Ursa Majoris, magnitude 14.1. Could be photographic. 318 million light years distant, means it's probably about 110K. RA is 113153 with a declination of plus 28, 21, 22. NGC 3715 is behind power line diffraction. Probably this one here, galaxy in crater, magnitude 13, could very well be 1.4 by 0.9 spiral with a lowercase bc. All we're seeing there is the core, 95 million light years distant, kind of small, maybe 40K. RA is 113132, declination minus 14 degrees, 13 minutes, 55 seconds. 3716 is maybe vaguely present in the field. I believe it is right there. Galaxy Leo, magnitude 13.5, 0.7 by 0.6 arc minutes, lenticular spiral, 302 million light years distant, maybe 80K in diameter. Right ascension 113141 with a declination of plus 3, 2915. Got to get moving. NGC 3719, after a couple of skippies too far north-south. Galaxy Leo, magnitude 13, 1.7 by 1.3 arc minute, spiral with a bar and a lowercase, spiral BC, lowercase. This one has an annularity, so I'm pushing up the magnification. Now, it could be this larger, fainter galaxy here. After all, it is a BC. This tends to have a brighter core. RA 113213, but we're right on the celestial equator, plus 49 minutes and 10 seconds. Let's see if we pick up the next one. Yes, indeed, that next galaxy was just a skip away. NGC 3720, Galaxy Leo, magnitude 12.9, 1 by 0.8, spiral with lowercase a. We nailed that one, 266 million light years distant, maybe 75K. Right ascension 113221 with a declination of plus 48 minutes and 14 seconds. NGC 3721 is a galaxy in crater. I only have my suspicions here. Magnitude 15, 1 by 0.5 arc minute, spiral with lowercase a, brightest core, 254 million light years distant. RA 113407, declination minus 9 degrees, 28 minutes and 1 second. No declarations about where it is in the field. Ooh, how about that? 3722, galaxy in crater, magnitude 16, photographic, 0.7, 0.7, elliptical, 284 million light years distant. As an elliptical, it's probably magnitude 14.5. Visual, I suspect this may be our galaxy. We're at RA 113423, declination minus 9 degrees, 40 minutes, 48 seconds. Ooh, there's another galaxy right over there. That might map. AdventuresInDeepSpace.com, folks. NGC 3723 wasn't too far from the last one. Let's see what we get. Ah, yes, there's something near the middle of the field. This may have been 3722, 3723. I think they're both worthy of pushing the magnification up. 23 is a galaxy in crater, magnitude 14, 1 by 0.9, lenticular spiral, 283 million light years distant, RA 113230, declination minus 9, 58, 10. NGC 3724, galaxy in crater. Centering that up, magnitude 15, 1.6 by 0.7. This is a very low average surface brightness galaxy. Maybe this one right there. There's a brighter galaxy off in this location, but this map maps better. Right ascension 113428 with a declination of minus 9 degrees, 39 minutes, and 35 seconds. I can go for that, but it's 1.6 by point. Oh well, AdventuresInDeepSpace.com for confirmation. NGC 3727, galaxy in crater, 105x view to begin with. Magnitude 14.5, 0.9 by 0.6 arc minutes, lenticular spiral, 207 million light years distant, RA 113340, declination minus 13, 5253. Let's push the magnification up a bit, and that reveals this is probably our galaxy, not a small double star, but there is an even fainter galaxy there, and possibly a brighter one there. NGC 3728, Galaxy Leo, magnitude 13. I think it's quite apparent there. 2 by 1.5 arc minutes, so it's got a fairly low average surface brightness. Well, it's got a bright core, spiral with a lowercase b, 317 million light years distant. This is a largie, maybe 180K. Right ascension 113315, declination plus 24, 26, 48. I'm going to push the magnification up, and then we'll head out. NGC 3730 wasn't visible in the field. We'll go up to, looks like it might be in this region here. Oh, there's kind of an edgy on thing there. Data has yet to come up, though. All right, so what I'm going to do is increase the magnification so we can use all of our photonage. This may look similar to the previous series of faint galaxies. This is in crater, once again, magnitude 14, 1 by 0.9 arc minute, elliptical, so it's likely to be this bright galaxy here, 186 million light years distant, RA 113416, minus 9 degrees, 34 minutes, 34 seconds. NGC 3731 may be present in the field. Yes, indeed. Kind of an faint, edgy on galaxy with looks like it has a brightish core, Galaxy Leo, magnitude 14.3, 1 by 0.9, elliptical. 146 million light years distant, but boy, that elliptical has wings. Right ascension 11:34:11 with a declination of plus 12 degrees, 30 minutes, 43 seconds, pushing the magnification up and then heading out. NGC 3732 at 105x is probably this galaxy right there in crater, magnitude 12.5, 1.4 by 1.2 arc minutes, kind of smallish. Spiral with a bar, lenticular A class, so quite mature. 76 million light years distant, RA 11:34:13, declination minus 9, 50, 45. And when I mention things like mature, etc., I recommend you see my previous video, 3650 to 3699, where I describe in text captions the process of galactic morphology, maturation in relationship to the type of light and its distribution in galaxies. So have a look at that. NGC 3734 is not particularly apparent in the field. There's something vaguish right there. Galaxy in crater, magnitude 14, 1.3 by 1 arc minute, spiral with a lowercase bc, so not a very bright core. 405 million light years distant, pretty large, maybe 150K. RA 11:34:40 with a declination of minus 14:04:54. NGC 3739 is kind of a faintish galaxy further north, and Leo, magnitude 14.4, 1.1 by 0.3 arc minutes. Kind of an edgy on, but oh yeah, I'm beginning to see it now after 4 stacks. Spiral with a bar, lowercase bc, with an annularity, but it's kind of tilted so hard to make out. 429 million light years distant means it's a largie. RA 11:35:37, declination plus 25:05:18. That's a star there. And here's a 150x view of 3739. NGC 3743. We've had quite a few skippies, either too far, mostly too far north. Oh wow, this one lined up perfectly in the center of the field. It's a galaxy in Leo, magnitude 15.6, 0.4 by 0.4 arc minute, compact, no morphological description, 486 million light years distant. Probably it's very small, maybe 60K. RA is 11:35:57, declination plus 21:43:23. Let's go ahead and do a 150x and get a better, brighter, larger view. NGC 3744 is a not particularly distinguishable galaxy in Leo, magnitude, and there's reasons, magnitude 15.4 photographic, 0.6 by 0.2. It's suspected in the field. Most things in Leo lined up pretty well. Oh yeah, that's probably our galaxy there. 316 million light years distant, RA 11:35:57 with a declination of plus 23 degrees and 41 seconds. Interestingly, the mount did a rather slow but distant roll to get to our next study, NGC. It's either one of these two. Let's see if we can figure it out. 3745 is a galaxy in Leo, magnitude 15.2, 0.4 by 0.2 arc minutes. It's a lenticular spiral. Fairly small, probably no more than 70K light years in diameter. Seems to be part of some kind of a group. Identifying which one is going to come down to our ability to suss out a lenticular spiral. 0.4 by 0.2 arc minutes. I am going to zoom in a bit, capture them all, and there's a few of them there. RA is 11:37:44 with a declination of plus 22 degrees, 1 minute and 16 seconds. Choose your best. As we might suspect, we were going to pick out some more galaxies in that series. I'm going to push it right up to 150x and then pause it and wait for a couple of stacks. Okay, NGC 3746 with 6 stacks plus, galaxy in Leo, magnitude 14.2, 1.1 by 0.5 arc minutes, spiral with a bar and a lowercase ab. There are so many galaxies here present. but it's a 2-to-1 aspect ratio. This may have been the first one we saw because we may slowly pick through them in the rest of the series. There's also a faint one here. This one looks most edge-on, possibly that one. I would go to adventuresindeepspace.com or possibly the Sky Live to track it down. It's got an annularity, 403 million light years distant, 1.1 by 0.5 arc minute, right ascension 1137.43, declination plus 22 degrees and 33 seconds. Okay, I'm just allowing the stacks to develop. There's over 23 of them now, so this galaxy group is far brighter and more distinct than it was. The one we're looking for is 3748 Galaxy Leo, of course, magnitude 14.8, 0.7 by 0.4 arc minute, lenticular spiral. Look for that bright core. 402 million light years distant. They're all roughly that distance, apparently. RA is 1137.49 with a declination of plus 22 degrees, 1 minute 32 seconds. We now have a total exposure time of 140 seconds for this galaxy group. Okay, that was the last in the series. I'm going to play a little bit with the histogram and see if we can't bring it out a little bit. Oh yeah, that's much nicer. Now I do have it set. There's the auto setting, and this is the manual setting where I try to track things down to give a little better view in terms of the aesthetic. And we've had an enormous number of stacks and a long period of exposures. And with that, I'm going to go back to 3707 because that's the faintest galaxy listed, 15.4 visual. Let's see if things have improved down there before we bail for the evening. Fortunately, we're only almost 27 minutes into this video, a bit shy of it. So we have an opportunity to explore this 15.4 magnitude galaxy that we had a hard time identifying before. But as Skydark has progressed, and I've noticed that the cloud cover tends to dissipate in the evenings, we are getting improved views. All right, so far we've had 6 stacks, which are normal for the maximum number of stacks, and it usually takes about 30 seconds to do them, especially if I initiate right after the first stack begins to accumulate in the field. NGC 3707 is a galaxy in crater. It says magnitude 15.2, but Steve Gottlieb at adventuresindeepspace.com, where I did a little pre-search, says 15.4. 0.6 by 0.4 arc minute sized elliptical galaxy. So all basically we're just seeing a globular cluster, massive globular cluster at great distance. RA is 1130.11 with a declination of minus 1132.36. I'll do a little bit of zoomage on this so you can see that, in fact, not only does the galaxy get brighter, but more of its texture is revealed and larger. More of its texture is revealed and it gets brighter. And that's up to 100% e-zoom, where we're using every pixel to gather light and feed it to the image stack. Clearly, this NGC 3707 has a aura around it. Now, it's possible that this isn't 3707, that it could be this one or that one. Possibly even that one or that one. There seem to be a number of galaxies in the field. It's going to take a little bit of research at adventuresindeepspace.com, where Steve will explain that possibly which telescope size he first saw it at, how it relates to other galaxies around it, possibly this bright star. If he does say it's probably something like 5 arc minutes east of a bright star, then it could be any of these galaxies, but he'll also list the other ones if they're visible. And if this is actually magnitude 15.4, these here would be at least a magnitude fainter and would probably require his 24-inch scope or possibly 48-inch eyepiece views to be able to detect them. 29 stacks now and 145 seconds of exposure. We've got a few more seconds left here. I do want to try a 60-second exposure on this before we bail, just to see if it works tonight. As it turned out, 60 seconds on this particular night could not find triangles to match in order to be able to do the intervening stacks that it has to do to shift things around before it presents an image to the laptop screen. But what we're about to get, I believe, is going to be a 70-second exposure. I'm sorry, a 30-second exposure. We've got our first stack. And I wouldn't say if this is our, assuming this is our galaxy here, it's probably just as well to do multiple stacks at 5 seconds than to wait around for a 30-second view. So in terms of real-time imaging, 5-second multi-stacks of about 5 or 6 stacks is probably the best way to go. It gives you enough time to be able to cite various observations, identify the galaxy, and get the data out. So I'm going to basically call real-time imaging, as far as I'm concerned, to be 6 stacks at 5-second exposure with a total exposure time of 30 seconds. And with that, I am going to zoom in once again. You know what? I might even take this further and say at 100, and let's see, this would be 300x 4 stack view, 120 seconds at 30 seconds, carpe noctem.